Okay, so hang tight. First of all, today we're talking about sum and difference formulas. Now, I have something to just kind of break up the monotony of taking notes today. Okay, I have what's called a foldable. So I want you to have it. So it looks like this. And then do you see this line right here? You're going to fold it like a book on that line. So that way when you're looking at the words sum and difference formulas, you see the three sum and difference formulas. So if you want to fold it on the line and then fold it back, but it needs to look like this.
What is wrong?
Yeah, so now you fold it the other way. The black line is the inside fold. Okay, so if you need to fold it and then fold it the other way, you know, do what you got to do. Okay, that way you see the word sum and difference formulas, and then you see the three sum and difference formulas. Okay. Now, please look up here. Once you have finished that, what I need you to do is I want you to open it up, and you are going to cut on those black lines only to the fold so that you have what looks like three little booklets. Okay? So cut on those black lines to the fold. So you have something that looks like this. Okay? When everyone's done with their scissors, you may return them. Okay, what I'm going to do before we get into these formulas is I am going to give you a proof for one of them. In mathematics, it's not just about writing something down, it's about writing something down that is correct, that actually makes sense, right? So in mathematics, we like to prove that things are true. Now, that might not be true for you, but pure mathematics is about proving that things are true or proving things are not true, all right? So these formulas didn't just come out of thin air. These formulas came out of mathematicians working with angles until they figured out something that worked for all angles, okay? So I'm going to show you one of the proofs. Now, technically, we have six formulas up here, okay? I want to point a couple things out, and then you can sit back and relax while I go through a proof, okay? So I squished six formulas into three. Okay, what this means is the sine of u plus v is sine u cosine v plus sine v cosine u. And then if you have the sine of two angles that are being subtracted, you're going to have sine u cosine v minus sine v cosine u. Okay? Now, look at the cosine one. Do you notice how that sign switches? That's because if you have cosine of u plus v, then you have cosine u cosine v minus sine u sine v. The sign from here changes to here. Okay? The same thing happens in our tangent formula. You notice how the plus minus is in the same place here, but then it switches in the numerator. So if this is addition, your numerator has addition, but your denominator has subtraction. If this is subtraction, your numerator has subtraction, but your denominator has addition. Now, some of you are thinking, Mrs. Holman, I'm never going to remember these. You don't have to. These will be given to you on the test or on the quiz tomorrow. These will be given to you on the test next week. Okay? All you have to know how to do is use them. Okay? So I'm going to go ahead and pause. real quick. Okay, we're going to start with our sine formula. So if you open that first little flap, you see the sine of pi over 12. Now, we do not know how to evaluate the sine of pi over 12. But could we take two angles that we know and subtract them to get pi over 12? What two angles subtract to be pi over 12? Okay, if we take pi over 3 and subtract pi over 4, we get pi over 12. So in order to evaluate the sine of pi over 12, we're going to treat our angle as pi over 3 minus pi over 4. Okay. Now, I want you to reference, okay, on the front flap, we're going to look at that formula. If I have two angles that are being subtracted inside of sine, it's the same as sine u cosine v minus sine v cosine u. All right? So we're going to rewrite this as the sine of u times the cosine of v minus, does yours say cosine u sine v? Yours does, doesn't it? Mine was the other way on the board. Let's just go with what yours says. Cosine u sine v. Okay? You are going to be given this formula. All that you have to be able to do is apply it. Okay? Do you see how on our first flap it goes? Have we got all that? Okay? So now it's a matter of us evaluating these. The sine of pi over 3. Kelsey, what is it? Radical 3 over 2. The cosine of pi over 4. Jen, what is it? Uh-huh. Good. Minus the cosine of pi over 3. Connor. Times the sine of pi over 4. Everybody. So what we have is radical 6 over 4 minus radical 2 over 4, which you can leave it like this, or we can make it 1/9 expression of a fraction. That's our answer. That's the exact value for sine of pi over 12. Now, if we put sine of pi over 12 in our calculator, give us a decimal, which approximates that. But that is the exact value. Okay? I know we have 1 minute before lunch, but our next example takes 1 minute. You already have it written down. That's pretty sweet. All right? What formula does this look like? The one we just did, a difference in signs, right? We have sine u cosine v minus cosine v sine u. So do you agree that this is the same thing as the sine of 120 minus 60? Okay. Yeah, I know we can evaluate all of those, but wouldn't it be easier if we just wrote this as the sine of 60 degrees? And Will, what is the sine of 60 degrees? You got it. Isn't that easier to do all that work instead of evaluating those 4 things and multiplying and subtracting? Okay. All right. It is lunchtime. When we come back, we will do the last 4 examples. Okay, so we did our first 2 examples. Let's move to our cosine examples. So let's go back in front of your, I don't know what to, I mean,
Isn't
flap.
mine covered?
What? Oh, look at the cover first and really soak in that cosine formula. What's nice about this, it's cosine, cosine, sine, sine, right? I'll go back and, yeah.
Really, can we go back to the last example? The sine of
Mhm.
What happened to the cosines?
Well, this followed that sine formula. Look at the front flap, that first one. Do you see how the sine of u minus v is sine of u cosine v minus cosine v sine u?
Yeah.
And then do you notice how this example follows that pattern?
Yeah.
So then we can rewrite it as the sine of u minus v.
Alright.
Does that make sense?
Yep.
Okay.
Are you giving us these formulas on the test or just the quiz?
Oh, yes, both. Like on your test, there will be like this box filled with formulas. These 3 will be on there, as well as what we learn Thursday. Okay. Okay, so next one. We want to simplify this expression. Do you notice how we have the sum of 2 angles inside of our cosine? Which means we can use the cosine sum formula to rewrite this. Okay, our cosine sum formula is cosine of u cosine of v. What operation do we put next? Minus. It changes. And so then sine u sine v. Okay. From here, let's go ahead and simplify what we know. The cosine of 3 pi over 2. Hey, what is it?
Cosine.
3 pi over 2. 0. Sine of theta and cosine theta we can't really do anything with. But we also have the sine of 3 pi over 2. Kanan, what's the sine of 3 pi over 2? Think about the unit circle. Where's 3 pi over 2? Show me like what the unit. Okay. What? There we go. All right. So, cosine times 0, 0. And then we have negative sine theta times negative 1 for a positive sine theta.
Isn't that like one of the properties? Like,
Yeah. Well, it's more of, they use like pi over 2 instead of 3 pi over 2.
oh.
But yes, there are some properties like that. They're called,
Not cofunction.
yes, cofunction. All right, questions on that one? Okay, now I know we have a quiz tomorrow, but so far what we've done, how do you feel? Has it been too strenuous? Okay, now do you need to practice this tonight? Yes, but it's really all about can you use the formula, okay? So this is our next example. You know how great it is? I don't have to wait for you guys to write things down. I love this. Okay, so we need to verify this identity. Which side should we start with? Probably the left side, right? Notice how we have the cosine and inside we have subtraction, right? We have a formula for that, don't we? Okay, so we have a difference inside of our cosine, which means we are going to rewrite it as the cosine of u times the cosine of v. Since it's subtraction, what goes in between? addition, because cosine flips, plus the sine of u times the sine of v. And we're proving an identity, and so we want to write all of it. Okay. Jackson, here's your co-function identity.
Yeah.
Okay. All right, so now what can we do? Okay. We actually wouldn't have to do that because we know what the cosine of pi over 2 is. Okay, so we can just evaluate it right now. What is the cosine of pi over 2? Okay. So since we are verifying an identity, I need to actually see that you rewrote the cosine of pi over 2 is 0 and the sine of pi over 2 is 1. I need to actually see that step, and then you can move to the third step, sine of x equals sine of x. Okay. There will be a couple identities for you to verify in your homework tonight, but they're all going to involve you applying these formulas. Okay. My suggestion to you would be to have these in front of you when you're doing your homework. Remember, you're not going to physically have this piece of paper, but they'll either be on the board or they'll be on your quiz tomorrow for you. Okay, let's look at the tangent. Now I'm going to go back to, go ahead and look at the very front of your foldable. Okay, our tangent formula, we already kind of talked about it, but notice the signs, okay? Those are the same. This one flips, okay? So the numerator will have the same sign as what's inside your tangent, but the denominator will flip. Okay, so let's go ahead and we have this expression to simplify. Okay. This will be good practice here. We have addition inside of our tangent, so we can use the sum formula here. So our sum formula says we need to take the tangent of u plus the tangent of v all over 1, remember this sign switches, minus the tangent of u tangent of v. Okay, so now let's simplify what we can. Tangent of theta, there's nothing we can do with that. Okay, now tangent of 3 pi, let's think to ourselves first, 3 pi is the same as what angle? Pi. All right, so the tangent of 3 pi is the same thing as evaluating the tangent of pi. All right, Caroline, what is it? Why is that? Okay, so here's 0, right? This would be pi. If we rotate to here, this would be 2 pi, right? So if we rotate 1 more pi, we'll be at 3 pi. All right? So tangent of 3 pi, what would that be, Hannah? It would be 0. Remember, this is a step I want to see. So anywhere there is a tangent of 3 pi, we can replace with 0. Oh, yeah. Thank you very much. That is important. Maybe not in this example, but all of the examples. Yeah, no, you didn't have your example. Okay. All right, so what is tangent theta plus 0? And what is 1 minus tangent theta times 0? 1. So maybe it would be more appropriate to say tangent of theta divided by 1, and then we can reduce it to the tangent of theta. That'd probably be more appropriate. Okay, so far we have seen examples where we have either proven an identity or simplified an expression. Okay, those have been very straightforward because the only option you really have had has been that sum or difference formula. Okay, back to our sign examples. That second sign example, we worked backwards with our identity or with our formula. But then that first example, we took an angle we didn't know how to evaluate, and we broke it up to a sum or difference of two angles that we did know how to do. Okay? Our last example is a tangent example where we're going to have to do that. 225. Just kidding. 255. Is that a special angle?
No.
It is not. Which means we're going to have to find the sum or difference of two angles to make 255 so we can find the exact value. Calculator doesn't give us exact values, okay? So, brainstorm at your pod ways to add or subtract two familiar angles to get 255. All right, pod 2, what do you have for me? 225 plus 30. Does that add up to be 255? Okay, does anybody have two different angles?
We had 45 and 210.
You have 45 and 210? Okay, anyone else? And no one did a subtraction? Okay. For some of these, there's going to be more than one way to do it. After we do this example, I'll give you a couple hints on what to try to look for, okay? This is going to take up a little bit of room, so you'll want to write small, okay? So, the tangent of 225 plus 30. Let's go ahead and apply our sum formula, okay? Our sum formula says we take the tangent of 225 plus the tangent of 30 divided by, our denominator is going to be 1. Now this is subtraction, tangent of u times tangent of v. Okay, ready for some fun? Tangent of 225. Jackson, what is it? That's nice, right? Okay. Tangent of 30 degrees. Ben, what's that one? Down below we have 1 minus the tangent of 225 is 1 times the tangent of 30 is radical 3 over 3. Okay. No matter what, when you do these problems, you're going to get something with a radical in the denominator. Do we like radicals in the denominator? No. With our tangent sum or difference formula, it's always going to be 1 minus the number or 1 plus the number. Okay? What is a way to get rid of a radical if we have a binomial in that denominator? Say what? We have to multiply by something.
Oh, it's the not the reciprocal thing.
Uh-huh.
Conjugate.
Conjugate. It is the conjugate. Okay. We multiply by the conjugate to numerator and denominator. Okay. Now I know we're going to have fractions and fractions, and we'll deal with that soon. Okay. But let's first focus on we don't want that radical downstairs. Okay. So we're multiplying by the conjugate. All right. So in our numerator we have 1 times 1 plus 1 times radical 3 over 3. Radical 3 over 3 times 1, so that happens twice. I'm going to go ahead and combine those. Plus, what is radical 3 over 3 times radical 3 over 3? Okay, radical 3 over 3 times radical 3 over 3 would give us 3/9, which we can reduce to 1/3. Okay, in our denominator we have 1 times 1. 1 times positive radical 3 over 3 and negative radical 3 over 3 times 1. Those two cancel out. That's the whole purpose of multiplying by the conjugate. And so the negative radical 3 over 3 times positive radical 3 over 3 is negative 3/9, which is 1/3. Okay, so this is what I would suggest now. We don't like fractions in a fraction. So let's make our numerator 1 fraction. Let's make our denominator 1 fraction. So these terms here, 2 radical 3 over 3 and 1 over 3 have denominators of 3. So I'm going to change 1 to 3 over 3. And then our denominator, we're going to do the same thing so that we can actually combine like terms. Okay. So all I did is I changed our 1s to 3 over 3s so that our numerator we can write as 4 plus 2 radical 3 over 3. And our denominator we can write as 2/3. Can you see the light? See the light. Okay. Now we have a fraction divided by a fraction. Let's remember back to our pre-algebra days that this just means we are going to take the numerator and multiply by the reciprocal of our denominator. The 3's are going to cancel. What's 4 divided by 2? And what's 2 radical 3 divided by 2? Here's our exact value. Now, no matter what, if you have a tangent problem for these sum or difference formulas, they aren't going to be only a few steps, okay? It's going to take a little bit of work. Now, what made this a little more complicated is that our tangent of our tangent of 30 degrees was radical 3 over 3. It was a fraction, okay? Tangent of 60 degrees, what is it? Radical 3, okay? So if we had a tangent of some 60-degree angle, we would avoid having fractions inside of fractions. Do you see what I'm saying? Okay? I would try as hard as you can for these tangent problems to pick a 60-degree angle or a 60-degree reference angle to do this so that you don't have to deal with fractions in fractions. Now, if you can't think of one, and you can think of a 30-degree one, then you're kind of stuck. But it will make your life easier if you can avoid that fraction in there. Okay? It'll save you basically this these two steps right here. Okay? You're still going to have to multiply by that conjugate, but it would save you those two steps. Okay? Now, your homework is some book work. And we have a quiz tomorrow. So our solving equations from yesterday will be on the quiz, as well as this. Now, I'm not giving you a review. Your review is the worksheet that you did last night and then the homework that you're going to do right now. Okay? If you have more than one question on your homework, you should probably try to find me or a friend before the quiz. Because we're not going to be able to spend 10 to 15 minutes up here doing problems before going to the quiz. Okay? Don't forget that Calc Chat is there to help you. All right? So reference Calc Chat if you are having issues with any of the odd problems. Okay? Now, I do want to talk about a couple of things because we haven't really gotten to talk about it here yet. Let me stop this.